Good day, everyone. My name is RAJADORAI. I'm the group leader of Group 2. Today, I'm here to talk about a small topic regarding manufacturing golf ball mold.
Assalamualaikum and I wish very good day. Today I'm going to discuss regarding any environmental issue concerning the existing process and on how to reduce it. Basically, in the existing process, there are four machining processes to involve that is direct metal laser sintering, or known as DMLS, was combined with high-speed milling, wire and die sinking, electrical discharge machining EDM in an integrated nearly automatic processing. Firstly, direct metal laser sintering (DMLS) is an industrial metal 3D printing process that builds fully functional metal prototypes. In a study, it's found only 6% of total process input of DMLS contribute to material processing. Other is lost as bulk waste, heat, and work. The systemic global warming potential was found to be 7.2 kg carbon dioxide equivalents, and this obviously lead to global warming issue and ozone layer depletion. How to reduce this? The best is use eco-friendly machining operation, improve efficiency in existing machining process, and also enhance the utilization of machine use. Moving on next is high-speed milling, a process that combines lighter milling passes with high spindle speed and high feed rate. The environment issue occurs is global warming, ozone layer depletion, and pollution. This is because of high electric consumption and also produces carbon dioxide emission including CH4 and N2O. In order to reduce this, we must use eco-friendly machining operation, improve efficiency in existing machining process, and also use non-toxic material to avoid pollution. Lastly, EDM process is established as an important non-conventional machining method because of its capability to machine very difficult to machine materials. The environment issue arises that EDM consumes huge amount of energy, release hazardous emission of gas, and generation of toxic dielectric ancillary. To reduce this, we must make development in EDM process such as hybridization to make safer process, and also make green EDM strategy to reduce environment effect.
Alternative advanced manufacturing process, electroforming. So by electroforming, a common additive manufacturing process is presented in this project of dimple golf mold. So what is electroforming? So it is a type of additive manufacturing that is used to create high precision metal components. Its distinguishing feature is the ability to create metal pieces atom by atom, resulting in exceptional precision and high aspect ratios.
Forming process. What is electroforming process? It is conducted in the electrolytic bath. A photosensitive coating is applied on a conductive surface. Only the areas that have been exposed to ultraviolet light through a mask will be targeted by the material in the electrolytic bath. Atoms from the cathode then pass through the bath and bond with the metal. The photolithography process determines the extreme precision of electroforming. Step-by-step electroforming process. Cleaning, coating, exposing, developing, deposition, and harvesting are all processes in the electroforming process which can be completed in a succession of phases. So, in this case, electroforming is applied in order to make dimples on golf mold. Step 1 is by cleaning. The conductive mold part substrate should be degreased and cleaned first. For the second step is by coating, which is light sensitive photoresist is then applied to the cleaned mold. The third one is exposing. So after that, the golf mold is subjected to UV radiation. We employ LDI, which is laser direct imaging technology, which is significantly more precise than conventional photo tooling. The LDI imager can project high resolution picture from a CAD file directly. Photomasks are rendered absolute in this method, lowering cost and shortening lead time. Fourth step is by developing. After the image is transferred by UV exposure, the substrate is then developed, rinsed and dried. Number 5 is deposition. The mold golf is deposited onto the pattern surface by an electrolytic bath. An electrolytic solution, 2 electrodes and a DC current are used in the electrodeposition process. A DC current is transmitted through the solution, which is electrolyte, transforming metallic ions into atoms that deposit on the cathode surface in a continuous deposit. Number 6, harvesting. Once the material has been plated to the correct thickness, the electroform item may be removed from the material.
I will continue this slide with the advantages of EDM die sinking. With EDM die sinking, there is no cutting process and neither tool nor golf ball mold rotate. In addition, sinking EDM technique may work wonder for our golf ball mold production, which is providing long-lasting products with high-quality finishes. There is no direct contact between the tool and the golf ball mold. The item can be machined without visible deformation. Cutting tough and complex materials is uncomplicated. With EDM die sinking, there's no polishing is necessary when the produce is complete if have a little amount of material. This allows for the cutting of thin materials without causing any damage. And the last, generate compartments that are opaque and have a high aspect ratio. Advantages of electroforming. The electroforming is the most straightforward method of creating internal cavities that use a long, narrow tube with a complicated construction that necessitated strict internal tolerance and precision. Surface detail reproduction with high dimension precision. For production of complex shape like dimple of gold and thin walled parts, as well as assisted with other mass production processes. When process tolerance, accuracy, lightweight, and tiny geometry are required, this is a significant competitor. This may be the only realistic or commercially sustainable production technology in this case.
Okay, hi, my name is Mohamad from BASET. I want to talk about limitation between existing and proposed process. So for the existing process, which is die sinking from EDM process. First, finishing cut are need a low MRR. That means the cutting parameter is low. Second, if we blind hole, it will produce tapered. So the third point will related to the second point, which is will produce hard skin to material. Limitation for the proposed process, which is electroforming. First, required single model, that means low production quantities can be met economically. Second, rate of production is normally slow. So for the third point, we related to the first and the second, which is this is not an economical method of production because it takes a long time to produce. Thank you.
Cost comparison between the proposed process and the current process. The proposed process, electroforming, they are quite similar process. When it comes to costing, they are almost the same when they are producing small volume parts. However, when producing large volume parts, the electroforming process is slightly cheaper than the EDM die sinking. This is because that not just that that process produce high precision part, rather the utilization of material is more conserved compared to EDM.